Good morning to all. Myself Vinaranjan Patnaik. Today I am going to discuss about the subject cryptography and network security, chapter number 3, symmetric and asymmetric key algorithm. So in this chapter, the following articles: symmetric key algorithm types, overview of symmetric key cryptography, data encryption standard, overview of asymmetric key cryptography, the RSA algorithm, symmetric and asymmetric key cryptography, digital signature. So first come to the symmetric key algorithm types. There are two types of symmetric encryption algorithm. Symmetric encryption is a type of encryption where only one key is used for encryption and decryption purpose. The entities communicating via symmetric encryption must exchange the key so that it can be used in the decryption process. And these encryption methods differ from asymmetric encryption, where a pair of keys are used. One is public key, another one is your private keys. So regarding the algorithms, there are two types of algorithm. One is your block cipher, second one is your stream cipher. So in your first come to the stream cipher algorithms. In stream cipher, the plain text is encrypted 1 bit at a time, and or you can say the stream cipher technique involves the encryption of one plain text bit at a time, and the decryption also happen 1 bit at a time. But in case of the block cipher algorithm, its set lengths of bits are encrypted in blocks of electronic data with the use of a specific secret key. As the data is being encrypted, the system holds the data in its memory as it waits for complete blocks. Next come to the stream cipher algorithm. This is the algorithm. In stream cipher, one byte is encrypted at a time, while in block cipher the 180 bits are encrypted at a time. Initially, a key will be supplied as input to pseudo-random bit generator, and then it produces a random 8-bit output, which is treated as key stream. The resulted key stream will be of size 1 byte, that is 8 bits. Stream cipher follows the sequence of pseudo-random number streams. One of the benefits of following stream cipher is to make cryptanalysis more difficult. So the number of bits chosen in the key stream must be long in order to make cryptanalysis is more difficult. By making the key more longer, it is also safe against brute force attack. Next is this is the stream encryption and decryption process. For encryption, suppose the plain text is 100110001. This is the bit, and the key stream is, that means one key stream is given is also, that is 11000011. So next you have to apply the JOR operation or XOR operation. In XOR operation, what will happen? Now the true is always false, and false always true. That means 1 is always 0, and 0 is also 0. In the above expression, 1 is 0, 0 1 is 1, 1 1 0, 0 1 1, 0 0 0, 1 0 1, 1 0 1, 0 1 your 0 0 01 is 100. So that is the ciphertext. Next is for decryption process, same thing. In place of the plain text, there is a ciphertext and the key stream is given. Then you have to apply the XOR operation. Next come to the block cipher algorithm. In block cipher is an encryption algorithm which takes fixed size of inputs, say B bits, and produce a ciphertext. Produce a cipher text of B bits again. If input is larger than B bits, it can be divided further. For different applications and uses, there are several modes of operation for a block cipher. Next is this block cipher. There are different type of algorithmic modes in the block cipher. So what is the algorithmic modes here? The algorithm mode is a combination of a series of the basic algorithm steps on block cipher and some kind of feedback from the previous step. So there are different types of algorithm modes. One is ECB, electronic code book, and second one is your CBC, cipher block chaining. Next CFB, cipher feedback. Next is your OFB, output feedback mode, and last one is your counter mode. So first come to the ECB, electronic code block. In electronic code book is the simplest mode of operation. Here the incoming plaintext message is divided into blocks of 64 bits each. 64 bits each. Each such block is then encrypted independently of the other blocks, and for all blocks in a message, the same key is used for encryption. And this process is shown in the as the below figure. In the encryption process, this is the P1, that means the plain text. K value is the encrypted, and this is the C1. Very simple method. That means plain text is given, key value is given, you have to apply and getting the ciphertext. Similar in the decryption method, you have applied for the ciphertext, applying the key value, decrypt that value and getting the plain text. It's very simple method. Next is your cipher block chaining or CBC mode. In the cipher block chaining method, it is a feedback mechanism method. First thing, the results of the encryption of the previous block as the feedback into the encryption of the current block. That means this is the one block. Whatever the result, that means whatever the ciphertext generated from the first block, it will be the input, or it will be the, or you can say it acts as input for the second block. Right? That means it is a feedback mechanism. Next is that each block is used to modify the encryption of the next block. Thus each block of ciphertext is dependent on the corresponding current input plain text block. So in the CBC process, this is the P1 and this is the IV, the initialization vector, and this initialization vector is nothing, it is a random block of text, right? It is the initial vector is given. Then after the key value is also given. After the encryption, the ciphertext is generated, and this ciphertext acts as a initialized vector for the next block. This process is going on. Again I am repeating, this P1 is the plain text, IVLI initialization vector, and this K is the encrypted value, K key value, then the ciphertext is given. This ciphertext again acts as the initialization vector for the next block, and the key is encryption and then cipher. So thank you for today's class. Next class we are going to discuss for the next topic. Thank you to all.